Recall, if h is the zero of a polynomial function, then x minus h is a factor of the polynomial. Now, if a polynomial contains a factor of the form x minus h raised to the p, the behavior near the x-intercept is determined by the power of p. Now, one thing is that we say that x equals to h, so the 0h is a zero of multiplicity p. Now, there are two things that we know, that the graph of a polynomial function will touch the x-axis but not cross at zeros with even multiplicities, and if they have an odd multiplicity, the graph will cross the x-axis at that zero. Now, another thing to note is that the sum of the multiplicities is the degree of the polynomial function. So just for an example, if we had a factor of, let's say, x minus 3 raised to the fourth, for example, and this is just one of the factors of the polynomial function. So we have some other stuff as well. But if it's one of the factors, then we know at 3, because 3 is the zero of the polynomial function, then since this has an even multiplicity, because 4 is an even number, this means that it'll touch but not cross at this 0. So it could go something like, it'll touch it but then bounce back up. So another way I've had some students say is that it'll bounce at the 0. Or it could also be at 3, again it'll go up, touch, but then go back down. Or for another example, one with an odd multiplicity, let's say if it had x minus 2 raised to the third, then at 2, for the graph, it would cross. So it could go from above to below, or from below to above. So this is one of the very useful things about the multiplicities of the zeros.